we've solved quadratics by factoring. We've solved some quadratics by taking square roots. But you can't always use either one of those methods to solve a quadratic equation. So a method that will work for absolutely every quadratic is this method called completing the square. So basically what it lets you do is it allows you to rewrite a quadratic equation as a perfect square that we can then solve by taking a square root. So our goal is going to be to take something like x squared plus 6x plus some number and turn it into whatever number it takes so that it factors as a perfect square. Like if it was x squared plus 6x plus 9, that would factor into x plus 3 times itself. So we're looking to create a trinomial that factors into something times itself. So geometrically, we're like physically making a shape that is a square. So let's start with what I have. If I have x squared plus 8x, then I'm going to draw a little square of x by x dimensions. That's going to represent my area of x squared. And then I'm going to draw 8 1 by x rectangles. Each one of them would have an area of x. So altogether, it'd be an area of 8x. So if you notice, that's really a big, long rectangle. It's not a perfect square. So what I'm going to do is I'm going to rearrange some of that area by taking half of my 8x and rearranging it so that the side lengths of my square are going to be x plus 4. It's not a completed square yet because I have that empty corner, but the sides are going to be the same length since I have the same number of x tiles or the same size on either side. So if you think about how many units it would take to complete that square, well, you could count them up if you draw it in, or you could think that's a 4 by 4 square in the corner there that needs filled in, so we need 16 units to have a completed square. So if C was 16, this would be a perfect square trinomial, because if you think about the side lengths of the whole overall square, it's an x plus 4 times x plus 4 area, which is the same thing, if you think about multiplying it out, as x squared plus 8x plus 16. We're going to use this process to solve some quadratic equations. So there's a list of steps here, but it's easiest if we just run through them with an actual equation. So the main thing that people tend to forget is when you add it to complete your square, make sure you add it to both sides. All right, so if a is not equal to 1, we need to make it equal to 1. Ours is, so that's done. Now we're going to rearrange it so that we have our terms that are variable on one side and our constant on the other. Done. Now I need to complete my square. So I have x squared plus 5x. That's not a perfect square. I'm going to figure out what I can add to both sides to complete that square and make it one. So if I kind of draw my area, I need to take half of this 5x area and move it so that my side lengths are going to be the same length. So half of 5 is 5 divided by 2. So I'll have 5 halves, or 2 1/2, on either side of my length. And that means my dimensions of my incomplete corner are 5 halves by 5 halves, which if you multiply that is 25 over 4. It's easiest to leave these in fraction form. That's why I'm leaving them as fractions. Then let's do some simplifying. We added that to both sides because it was an equation now. We needed to keep it balanced. If I rewrite my left-hand side as the factored form, that's perfect square trinomial, look at the side lengths of your whole entire square. That's an area of x plus 5 halves times itself. So write it as x plus 5 halves to the second. You could instead factor and look for like the two numbers that multiply to 25 over 4 and add up to 5 in the middle, but you probably don't want to do it that way. It's easier just to look at your square that you drew, think about its side lengths. And then on the right-hand side, if you get a common denominator and actually add those together, you get 49 over 4. Now we've got it set up so that we have a perfect square, which means we can solve it by taking the square root of both sides. So the whole completing the square process is done. Now we can solve it like we did before. So take square root of both sides. You get x plus 5 halves equals positive and negative 7 over 2. And then to get x by itself, subtract 5/2 from both sides. You could write two separate equations or one sort of condensed version. Either way though, since you can actually do -5/2 plus 7/2 and -5/2 minus 7/2, you need to go ahead and add those and subtract them. So you'll end up with 1 and -6. So those are your two solutions. All right, let's run through this one. So at some point, it's not 1x squared, so we'll have to make it 1x squared, but let's get all the x squareds together first, which will give us, if we subtract x squared from both sides, that right there. And then, like I said, for completing the square to work, we need a coefficient of 1 on our squared term. So let's divide everything by 3 on both sides of our equation, which will make it 1x squared minus 12x plus 50 equals 0. 50 isn't the right number for completing in our square. That doesn't make it factor as a perfect square, so I'm going to subtract 50 from both sides. I like to leave myself a little blank there to remind myself that I'm going to have to complete my square and add whatever constant it takes to both sides of my equation. So let me draw a little sketch here. I have x squared minus 12x. So right now this is not a perfect square. Whoops, that's a 12x. So I'm going to need to rearrange it. Well, squares have equal side lengths. Cut that 12 length in half and make it -6 on both sides. Yes, I know it's a little weird because I'm looking at area and I have negatives, but go with it. It's the model that's helping us. So that little corner in the lower right is dimensions -6 by -6, gives you a positive 36. So 36 is the number of units it will take to complete your square. So let's rewrite it as a perfect square. So factor it into x minus 6 times itself by either looking at your side lengths of your square, or you can go through and find the numbers that multiply to 36, add up to -12, and go through your factoring process. Then you get to take the square root of both sides, which square root of -14 gives you plus or minus I square root 14, and then add 6 to both sides, and you are done. So now we're going to choose whichever method we think is the most efficient to solve our problem, or maybe whichever one you like the best. I'm going to try factoring this first one because it looks like it would be a pain to complete the square on. I'd have to divide everything by 4 to get a 1x squared, and then I'll have fractions and a middle term, which is 23 over 4 that I'll have to cut in half. It'd be a mess. So I'm going to try factoring and only resort to that if necessary. So when I'm factoring, I'm going to be looking for two numbers that multiply to 4 times -6, or -24, and add up to -23. I could guess and check it, but I'd rather just use my grouping method here. So those numbers would be -24 and +1. So I'll rewrite my -23x as -24x plus 1x. And then I can look at breaking this into a couple of groups and factoring out a common factor. So I can pull a 4x out, which leaves me with x minus 6. And then I have to factor something out, so I'll just take out a 1 because it won't change it. My two groups share a factor of x plus x minus 6, and then I'm left with 4x plus 1. So by the zero factor property, I can set each factor equal to 0 and solve. So x minus 6 equals 0 and 4x plus 1 equals 0 when x equals 6 and x equals 1/4. Much easier than completing the square on that one. If you look at B, the quantity on the left is a perfect square. So I'm just going to go ahead and start by taking the square root of both sides. No completing the square necessary. Then I can break down my square root of 8 into plus or minus 2 square root 2. Subtract 2 from both sides to get x by itself. And you end up with -2 plus or minus 2 square root 2. I could have multiplied x plus 2 out times itself, but that would have been a lot more work than just directly taking the square root to start with. On this one, it's tempting to complete the square, but if you look carefully, that's not a 4x, that's just a plain old 4. So let's get our x squared by itself and take the square root of both sides. Subtracting 4 from both sides gives you 2x squared equals -11. divide both sides by 2, and then we'll leave it as negative 11 over 2. To undo our square, go ahead and take the square root of both sides. I know I wrote x squared, I'll fix it in a second, it's just x. And then I'm going to break it into square root of the numerator and denominator separately. Square root of negative 11 is I times the square root of 11 all over the square root of 2. We need to rationalize, so multiply by square root 2 over square root 2 so that we no longer have a radical in our denominator. You're going to end up with a final answer of plus or minus I square root 22 over 2.